Right. Today we are going to discuss a very important concept called linked list. See, first of all, so what is linked list and how can we construct? Whenever we are learning the concept of, whenever we are learning the concept of has a relation, we have already discussed that in has a relation, in a has a relation. See, this is has a relation. This concept I have already explained clearly. I have already explained. So what is that? Normally in a linked list, we are representing the data using the concept called nodes. Nodes. So here, based on that, we are writing the code also. It's a linked list data structure. Suppose I'm giving the name directly linked list data structure. Or just linked list I'm giving. Linked list I'm giving. Okay. Here, to perform all the linked list operations, you need to create the node. See, this is actually the representation, but in the background, we need to create the object for the class. This is how we need to create the class. It is representing each node in the list. So here we are taking that class is a node class, which contains two things. See, one is a data, second one is a link. One is a data, second one is a link. First one, data we are taking. Second one is a link we are taking. Link. Link is a node type. Sir, why? See, look at this. Link is holding the address of another node. Is holding the address of another node. So initially, you need to take one variable called root. We need to take one variable. It is common for all. So static variable, which is which type, is a node type only, root. Of course, the default value is a null only. See, whenever you are printing this one, it will show that value. It will show that value by default is a null. But explicitly, sometimes we need to specify, because if they ask us, sir, what is the default value means what? No need to explain that. Static variables automatically initializes with the default value. Class variable is nothing but pointer variable. So class type variable default value is a null value. So that is no need to specify like this. No need to specify like this, simply. So in this one, now root value is a null, that no need to represent. No need to represent that one. Now here, we are just creating the methods. Sir, first of all, append method I want to create directly here. Static void. Appending means what? Adding at the end. What is the data? The data we need to specify. I mean, what is the element you want to add? That is. Next one more is a display also I am writing. Display all the node details. First, we will discuss only these two for today. Appending the elements, appending, adding at the end. So first, the first one, just wait. Right. The first one, as usual, we keep that. And here it is. We are writing initially, because based on this, now we are writing the code. initially that root value equals to null. Root is having the null value initially. Is the first step. Is the first step. So whenever you want to send one value, sir, how can we? Remaining is the same story. Scanner SC is equal to new scanner of system.in, and while true, this condition is true. We are importing that. We are importing that. And inside this one, only the things are what? First one is append. First option is append. Second option is display. Second option is display. That's all. Third option is exit. Third option is exit. So first we ask, enter your choice. Enter your choice. So that we are reading. And here, if the choice is equal to 1, else if this story is a common story that you know. So quickly I'm writing. If the choice is equals to 3, just quick exit. Exit. This is the one. If, else if, else if, else. Like this we have defined. So first option is if choice is equals to 1, that is for append, adding at the end. Append, adding at the end. Sir, how? First we need to create one node. First we need to create one node. Sir, how this node will be created? Suppose at some location, address. So address I'm just considering it's 1,000. It's 1,000. Sir, how? Suppose if choice is 1, just we ask enter element. Enter element. Okay. So that we are collecting. And we are calling the method append of element. Append method we are calling and that we are passing. First step is what? You have to create the object. For what? If you create the object for this class node, then memory will be allocated like this. At some location, here just generally I have taken it's 1,000. So here what we have to do? Simply node, okay, object, any object name. Suppose n is equal to node n is equal to or node object is equal to new node. Simply. So now that element you are adding at this place, suppose consider this is data and this is link. By default, link will be null only. Remember that automatically. Data will be 0. So, but you have to place this element to this node. To this node. Simply object dot data equals to element. We are adding whatever the element, consider 10. The 10 will be added here. So node is ready. But initially that node will store into obj or one temporary variable to make you more clear. Temp is nothing but initially that 1,000 will be stored into temp. Now we need to check, okay, the complete node is ready. Now where I have to place this node? where I have to place this node. Sir, is it the first node or already nodes are present in the list? Is it the first node or already nodes are present in the list? Sir, it is the first node. How can you say that? Sir, root is null. Root is nothing but first. Sir, still it is not pointing to any node. So newly what we have created, that is only the first node, sir. Okay. So how can you say that it's a first node if the root value equals to null? If root equals to null, else remaining that is later. If root equals to null, then directly this temp value will be assigned to root. Assigned to root. So that is, suppose that 1000 will be added here. So it is pointing to this one. So first node is ready. Simply temp value will be stored into root. Temp value will be stored into root. That's all. Node created. Message here you can write simply. Node or element added. Element added to list. Simple one. Sir, when else block execute means what? If it is not the root node. See, suppose consider so many nodes are there. Already 3 nodes are there. Just consider is a second node and is a third node. Then you will get clarity when multiple nodes are there here. When multiple nodes are there. Suppose the second node is created at address is 2000. Third node is created at address is 3000. And the data will be stored here 20. And the next node address is 3000 is a 30. And no more node here null. And in this place first the 2000 will store. So null already deleted. Already nodes created like this consider. It is pointing to this and it is pointing to this. Consider 3 nodes already present in the list. Now they have called this method called append method passing 40. Now we need to connect the value 40 to the list. So first node we have to create this node. Here, this is the node. This is the node that we are creating here. Creating here at address, suppose 4000. Initially, the 4000 will go and store into that variable called temp. So initially, temp equals to 4000. Temp equals to 4000. That element will store into temp2 data. Temp2 data. So 40. Already it contains that null. So our node is ready, sir. Now where we need to connect that node? Where we need to connect this node? Sir, for this node we need to connect. Then how can you consider means what? How can you travel to this node means what? From the root node. So if it is not root node, we are taking one more extra variable node last equals to root. Sir, what is this meaning? I am going to find out the last node. Now that is I'm going to start searching from the first node. Searching from the first node. Here, suppose I'm taking here last is a starting with the root. What is the root value? 1000. The root value starting with the 1000. See, root value 1000. Na? So that is you are assigning to the last. So last value is a 1000 consider. Here, 1000 consider. In this one, what happened? Now we need to travel. Sir, how many nodes are there? We don't know. But still we need to find out the last node. Sir, how it is possible? It's very simple. If we don't know how many times you have to repeat the loop, while loop. If you know how many times you have to repeat the loop, it's a for loop. So now we go with the while loop. While that last two link is not equals to null, until last two link not equal to null, store that last two link into last. So what is this meaning? See, sir, what is this last 1000? 1000 to link. What is a 1000 to link? 2000. See, 1000 to link 2000 is not equals to null. Yes, 2000 is not equal to null. So the 2000 will come and store into this last. So the 2000 will come and store into this one. Okay, sir, again loop will repeat because it's while loop. How many times it will repeat? As long as the condition is valid, it will repeat. So 2000 to link. 2000 to link is what? 3000. 2000 to link is a 3000. Yes, 3000 is not equal to null. 3000 is not equal to null. So 3000 will come and store into this last. So here, in place of this last, what is the value will store? Is a 3000 will store. 3000. Now last is pointing to 3000. Look at this. Last is pointing to this 3000. Where we need to connect, we already reached. So finally, all you have to do is a simple thing. This temp you need to store in this location. In this location, 3000 to link. 3000 means what? Last. To the last node link, you have to store this newly created node. That is temp node. Temp node you need to add here. For that, we are writing temp value store into last two link. Temp value store into after while loop. Temp value storing into last node to link. Once while loop execution completed. Once while loop execution completed, the temp value will be stored into last two link. That is. This is the last one. I mean, when multiple nodes are already there, then how can we add that node to the list? That is. Okay. Now see, sir, simply we keep on adding like this. And sir, just checking the nodes are added or not. That is the second option. If the second option they clicked, directly display method we called. Directly display method we called. So in display method, what we are doing? First, we are checking if root equal to null. Directly we can say that list is empty, nothing is there to print. List is empty. List is empty. If list is not empty, root is pointing to something. Root is pointing to something. Suppose now, and this once execution is completed, this 4000 simply will store into this place. 4000 that we didn't write. 4000 and it is pointing to this. And it is pointing to this. Okay. This is simple. These are the nodes available. Sir, now I just want to print. Okay. Repeat the loop. Sir, how many times? We don't know how many times because how many nodes are present. So starting from the root, take one temporary node that is starting with the root. If the temp is not equals to null, yes. What is the temp value starting with? Temp value starting with the root. What is the root value? 1000. Yes, 1000 is not equal to null. 1000 is not equals to null. Condition is true. So print first the temp to data. Whatever the data is present in that node, 1000 to data means 10 will print. Next, it should pointing to the next node. Na? So into the temp, store temp to link value. Temp to link value is a 2000. Store that into temp, store temp dot link value. It is pointing to the next node. Sir, next node is completed, then it will become 3000. So 3000 to data will print. So 3000 completed, 3000 to link, value become 4000. Value become 4000. Sir, 4000 completed, then 4000 to link, null value will store because 4000 to link last is a null value is there. So while null not equal to null, sir, condition fail. Sorry, not if block. My mistake, na? While temp not equal to null, then is keep on printing. This is the simple way of implementing that single linked list in Java, but only two operations, append and display. See, enter choice, I keep on appending. Choice 20, 30, 40, 50. Sir, I want to display all. See, 10, 20, 30, 40, 50. Sir, again, I want to append 60, 170, 180, 190, 100. Sir, I want to display. There is no limitation. We keep on adding, we keep on adding, we keep on adding. That is okay. Only try to understand this much code for today. Once you have completed all the things, add it first, add after, finding the total length, right? Delete first, delete after, swapping the data, searching the data, all the operations we can easily do in the next class. But today you have to complete mainly concentrate on appending as well as display because remaining all codes based on these codes only. Practice multiple times.